So I took that thing we did before, and I jotted it down because I wanted you to have it in your notes. That way when you study, you have that. I didn't want to print out a whole other sheet of paper just for some of that stuff. So I noted the x value is always time, the y value is always the height. The max height is your vertex. The maximum height, you use your vertex, I should say. It's not your vertex, you use your vertex. Now, the reason I say you use your vertex is because the x value of your vertex, remember a vertex is an ordered pair, the x value is how many seconds it takes to get to the highest point. The y value is how many feet the highest point is. So if I ask for the maximum height, you're finding the vertex, and that y value is your maximum height. X value is how many seconds it takes. That's how our problems are going to go. All our problems will be in seconds. You technically, it could be minutes, could be hours, could be. That said, if you can throw a ball and it's in the air for minutes, then you're going places. You probably don't need this class. You'll probably be a professional athlete at some point. And if you're not on Earth, you already are somewhere. You also don't need this class. Then we'll talk the x-intercept we talked about. That's how long it takes to hit the ground. And I put that down here. If you want to know how long it's in the air, how long it's ground, that is the quadratic formula. So I wanted to add every time you're finding when it hits the ground, how many seconds it was in the air, what the hang time is. That is that terminology. You use the quadratic formula. And then the y-intercept is always how many seconds until it's The y-intercept is always how tall you are, what you're standing on before you throw it, or before the thing goes. Last but not least, you cannot have negative time. That'll come into play a little bit later, but make sure when you solve, if you get an answer that is negative, that is not your answer. You cannot have negative time. I guess to stick with our example, if you can throw a ball so hard and fast that you go back in time, again, probably don't need this class at all. And we need to talk. Because the government's going to be looking for you soon. I've seen it 1,000 times. Okay, so before I start this, again, I will say, it's intimidating, but really when it gets down to it, it's not too bad. It's just there's a lot of answers we'll get from this one formula. The good news is, all these answers you get are the same answers for the next one, are the same answers for the next one. So this is your practice test. So we're going to probably cheat sheet we go a lot of, but this is the new test. So for this first one, a diver is diving off of a high dive. That's a lot of, I didn't realize I used the word dive about 4 times in that sentence. Diver is diving off a high dive. During her jump, her height can be modeled as this function. So again, I could have made this problem harder by not giving you the function, making you find the function, but I didn't want to do that. So there you go. So once we know the function, again, that's all we need to know. We can find out all this information. So 1, how high was the diving board? This is your favorite one. 32. That's it. That is the y-intercept. Now, if you want to know the technicalities, I told you earlier the y-intercept beginning at 0 seconds. So at 0 seconds, if you put 0 into x, 0 squared is 0 times 16 is 0. So that's 0. 8 times 0 is 0. All you're left with is 32. That'll always be like that. The only time it's not is if something's in vertex form, and we can go over that, and we won't go over that. So the y-intercept is always that constant at the end. How high did she jump? Now, when I say how high, hopefully it's obvious. I'm asking for the maximum. What's the maximum height she reaches? Now, I will tell you, since I know ahead of time, obviously you don't have to ask them in this order. Maybe on that number 1 won't be the how high she started. Maybe that's going to be the 4th thing to ask. So it doesn't have to be in the same order. But how high she jumped and how many seconds it took her to reach that height is actually going to end up being the same problem. The reason is because our 3 of this is the axis of symmetry. How high did the taper to get to that maximum? So what's the x value of that maximum? And then you're going to use that to find what the y value is of that, again, the vertex. So it's the x value of the vertex, it's the y value. So, I'm going to do all my work in number 2. We'll talk about that in a second. But my first step is finding my axis of symmetry. And again, this is no different than what we did with graphing. And that's why we do this one second, right after we did graphing. When we graphed, and I told you to find the vertex. On the quiz I'm going to hand back to you guys, there are questions that just said, find the vertex. So find your axis of symmetry, plug that back in to find your vertex. So my axis of symmetry is negative b over 2 times a. So that's negative, my b is 8 over 2 times negative 16. 8 over negative 16. Put in your calculator, should be 0.5, I believe. Yes, question. Absolutely right. I got that because I was thinking that that's different than what I got in the last class. Thank you. Yeah, 2 times 16, fun fact, is negative 32. It is not 16. So 0.25. So after 1/4 of a second is where she's at last. Or something because broken glass shards. But once you have that, again, with our vertex, that is the x value of our vertex, but we still need the y value. So y value, take that x and plug it back into your equation. 8 times 0.25 squared plus 8 times 0.25 plus 32. Again, this is weird, but you can use a calculator, so don't be too intimidated. Make sure you're using parentheses when you need to. I just always do that. Always use parentheses. Type that in your calculator. And again, we did this in the graphing lesson. We did this a bunch of times. So hopefully, that gave me 33. The vertex is 0.25 and 33. So what is the maximum height? Remember, the x value is the time. The y value is the height. So our maximum height is 33. Now, I will say, just for technicalities, if you just put 33, or I guess I should say, if you don't put your answer as a vertex like this, that's fine. Because I'm not asking for the vertex, I'm just asking for the maximum height. But there were a couple students on the quiz that when I asked for the vertex, they did not put it as an ordered pair. So make sure if it asks for the vertex, I do need an ordered pair. If in doubt, write the ordered pair somewhere. So we just talked about this, but part 3, how many seconds did it take to reach that maximum height? Well, that's the y value. Or sorry, the x value of that vertex. So you do not need to redo your work. You do not have to redo your axis of symmetry. All you have to do is 0.2 seconds, and I will see that. So I don't care if you put your axis of symmetry, if you show that work on number 2, and not number 3, or vice versa. If you say, oh, well, obviously I have to do this one first, so you put your axis of symmetry work down here, and then that work for number 2, that's fine. As long as I see it once, that's the main thing. But I do need to see it. So that's the vertex, or that's the maximum height. Find the vertex. The x value is your number of seconds it took to get to that height. The y value is your height. Now, this is the one that it's not bad, but there's just a lot going on. How many seconds is it in the air before it hits the water? Or how many seconds is she in the air before she hits the water? Remember, if it's how many seconds are in the air total before they're on the ground or on the water where their height is 0, you're solving it. So we're going to suggest using the quadratic formula. Do not use factoring. Sometimes factoring will work, but very much. A is 15. My B is 8. 32. And I know it's going to look a little Go ahead, plug it in and put it in your calculator. So I have my B minus B squared, so 8 squared minus 4 times 10. I will tell you, I will tell you that a lot of people are not putting parentheses in. Honestly, for these problems, it'll work out okay if you don't, because your T is positive on all of them for today. But on the quiz, some people miss some small points. It was all because they have a negative number here and they use parentheses. So when they squared it, it didn't work well on the calculator. So again, I would strongly recommend always using parentheses numbers in. Just like when we did quadratic equation before, if you want to skip over this next step, you can, but I clean everything up. Makes it look a little bit nicer. And square root, we have 8 squared minus 4 times negative 16 times 32. I feel like that's not right. Ah, it's because I have a plus instead of a minus. Okay, hold on, sorry. We'll get through this. Much better. So when you solve this one, and again, you can skip this orange step. If you want to put this whole blue step or purple, whatever this color is, you don't put that in your calculator, not worry about this at all, that's up to you. But I do need to see that blue step somewhere. So we have negative 8 plus the square root of 2112 divided by negative 32. So that's negative 1.19. Please round to 2 decimal places. Then we have negative 8 minus square root of 2112 divided by negative 32 is positive 1.69. Now, here's the thing that some people, I'm choosing to believe that people just forget. People just don't think about it. But this is how long it was in the air. You cannot have negative answers. Again, you threw a ball so hard you went back in time. That rarely happens. That sounds like a movie that I'd be like, let's not watch that. So this has to be your answer. 1.69 seconds is how long it was in the air. So some students say, do I need to put that other answer down? Technically, you don't have to, but if I were you, I would write it down. I'm not going to make you, but I like to write it down and throw an X through it, so at least know you did have the answer and you know that it's wrong. If you do this whole problem and get the wrong answer over here, but then you have this down where you crossed it out, I might give you some proper credit because you at least know enough that you know what's going on with that one. That's the hardest part of this. Then the last one. What is her height after 1 second? Well, again, if I ask what her height is and I give you a certain amount of time, all I'm doing is I'm giving you the X value. You just need to plug it in the Y value. Times 1 plus 32. Plug that in your calculator. 16, negative 16, parentheses, 1 plus 32. Into her jump, you would have started watch 1 second into her jump, she was 24 feet. So, not to, I hope this doesn't confuse you at all, but before we move on and before I take questions, I want to point out the notes I kind of had before we did the notes that I was talking about. This graph right here is that graph of that first one. So we said our vertex was at 0.2533, so after 0.25 seconds, it was 33. That's this vertex. We said it hit the ground after 1.69 seconds. So that's what this graph is going to look like. So why was one of your answers negative? Well, when you normally graph this, this still goes down here, and that's going to give you a negative answer. So that's why we can't have that.
And again, when I said what's the height after 1 second? Well, 1 second is right here. That height hits about right here. And if you go over, that X value or that Y value is just about at 24. So that's what that whole thing is telling you. Now, last thing before I go on or ask for questions. I know that that's a lot. The only difference is that you have bigger numbers. We've had it before. Solved using quadratic formula. We've done that before. And everything else really is same. Any questions on that before we move on? So we're going to move on. And again, this first one, or the second one, you're going to see it's almost exactly the same scenario. We have a different formula, but it's a very similar formula. Just for what it's worth, if some of you guys are noticing this pattern, this negative 16 happens for every single one of these problems, mainly because I want to be realistic. But that negative 16 is your acceleration due to gravity. So I know, again, you don't need to know this at all, but if you're interested at all, if you drop something off like a super high building, after the first second, it would go 16 feet. After the second, it would go 16 squared. After the next second, it would go 16 to the fourth, so on and so forth. 80 is the velocity. So if you go back to the this girl that jumped off the high dive, it's kind of funny because if you think about it, not telling her she should quit, but she jumped 1 foot off the high dive. She went from a 32-foot platform, jumped a foot, and then started coming down. Well, the reason for that is because she had an initial velocity of 8 feet per second, which is not great as far as if you're doing something explosive. Anyways, thought maybe if you're an athlete, maybe that would be something interesting. Probably not. I was probably wrong. That's okay. Same thing with this one. Again, we do a little bit of a different scenario. This weekend, I was at Topgolf for the first time. That's fake. I've not ever been there. I hit a ball, wrote a function that represents the height after I hit the ball. This is the function. So this is the height compared to the number of seconds it was in the air. How high did I hit the ball? 20 feet. That's the y-intercept. I'm sorry. Let me rephrase. How high was I off the ground when I hit the ball? How high was I at the very beginning? Again, that's 20 feet. That's your y-intercept. It's ever at the beginning or before you started the trial. That's always your y-intercept. Now again, how high did I hit the ball? Just like the last one, we're going to find the axis of symmetry in the vertex. So the axis of symmetry, I have negative 80 over 2 times negative 16. So negative 80 over negative 32. You got 2.5 for that. Then plug that back in. So negative 16 times 2.5 squared plus 80 times 2.5 plus 20. Again, just plugging that into your formula to see what the height is now, the y value. That ends up being 120. So 120 feet is the highest it'll be. Vertex, the highest point, is going to be 120 feet off the ground. How many seconds did it take to get to that 120 feet? Well, that's that 2.5. That's the axis of symmetry. Again, we move on to the next part. How long was the ball in the air? So how long was it total in the air before it hits the ground? That is your quadratic formula. Excuse me. Plug these into your quadratic formula. 80 squared minus 4 times negative 16 times, I'm not going to be able to fit it in, 20. All over 2 times negative 16. Again, this is the part that I always do, but you can completely skip if you want. That's negative 80 plus or minus. And then we have 80 squared minus 4 times negative 16 times 20. And then the answer to this one. So when you solve this, again, you get two answers, one with the plus, one with the minus. So negative 80 plus square root of 7680. That divided by negative 32 is negative 0.24. And then the other one, negative 80 minus the square root of that divided by negative 32 is positive 5.24. So again, you don't have to show this, but that 24 is not the answer. It's got to be 5.24. That's it took for that ball to hit the ground. And number 10, what is it after 2 seconds? Again, you're plugging into your original equation. That's negative 16 times 2 squared plus 80 times 2 plus 20. Negative 16 times 2 squared plus 80 times 2 plus 20 is 116 feet. So after 2 seconds after I hit it, 116 feet. Very often, but also remember your height also has to be positive. So if you ever, if I say, so how high is it after 7 seconds? If you plug 7 into that formula, you get a negative number. What does that mean? Well, we already said it's only in the air for 5 seconds. So if you get 7 seconds, it means it hit the ground at 5 seconds and it's still on the ground. I guess we're not doing elasticity or anything. Confusion. Any questions on that one before we move on? Now, again, you will not hear me stand up here and say this is easy, because it's not. I do lie to people a lot. This is not something I'm lying about. This is not easy. But, again, I assure you, this is the only type of question I'm asking. I'm not going to give you this and then on the test say, there's a bridge that has an arc, and if you solve this, how long is the bridge and how high is it off the ground? No, this is the type of question you'll have on your test. There's 3 types in the notes. You'll get 3 types in your homework. And it's going to be the only thing, actually, the only other thing on your test, I actually don't ask all those questions. But if anything, those are the 5 I'll ask. So, if there aren't any questions, go ahead and do the you do problem. I'll give you those answers here in a second. Okay. So it's not supposed to be negative. And that's 64.77. I couldn't fit the second 7 on there. What? Was that Miss Cole? Yes. Right, so those answers are up there. Max, or how high he was off the ground when he threw the banana was 55 feet. The maximum height was 64.77 feet. The number of the amount of time that took to get to the maximum height is 0.78. It hit the ground after 2.79 seconds, and after 0.5 seconds, it was 63.5 feet off the ground.